Okay, hello. This is the last lesson for atomic structure of the atom, and this is kind of based on a lot of the questions that I've been noticing for AP practice exams and on the exam. So I really wanted to tailor this to helping you guys out with that. So Aufbau diagram, this is probably something you saw in regular chemistry or chemistry. This may look familiar, but essentially what it does is it orders all of the atoms, all of the orbitals in terms of lowest energy to highest energy. And this is actually the unshortcut version of the periodic table method you guys have been using. But you want to know a little bit of how to fill this out. And for the most part, the AP exam, I've seen them concentrating further down here. They really don't get into the higher D's and higher F orbitals. They like to stay on the upper half of the periodic table, unless we're talking about like nuclear chemistry or something. So there are three general rules you need to follow for filling this diagram. The first one, you must fill orbitals from low energy to high energy. That means when you put in electrons, they go from 1s to 2s to 2p to 3s to 3p, 4s, 3d, 4p, and so on and so forth. You put one electron per orbital before pairing, and that's really going to show up when you hit the p orbitals and d orbitals. And when I fill one out, you'll kind of see what that's like. And the orbitals, whoops, my face is in the screen, they have to be of opposite spin. So how we denote spin is we just use arrows, either an up arrow or a down arrow. This is what I tend to do. On the exam, you might see something like up arrows and down arrows like this. They're the same thing. And what they relate to is the magnetic spin of the electrons. You just can't have two electrons with the same magnetic spin. They end up repelling. So let's pick one. We're going to pick copper because I talk about copper later. Copper has 29 electrons. So 29 electrons have to fit in these orbitals. You start low energy, fill out both orbitals, opposite spins. That's 2. That's 3. Now we get to 3 orbitals, 1 electron per orbital. That was 4, 5, 6, 7, 8, 9, 10. Okay, go on to the next one. That's 11, that's 12, 13, 14, 15, 16, 17, 18, 19, 20, then 21, 22, 23, 24, 25, 26, 27, 28, 29. All right, so we have that at the end. All right, I'm just going to focus on this end part of the configuration here. I'm not going to write all of the rest. I'm just going to focus on the end part. That doesn't mean you don't write it, but this is the part I want to focus on. Okay, so again, we know copper has one of these configurations, and why I'm bringing this up again is it ties into ground state and excited state later on. So this is an unstable configuration for copper, and that actually exists for silver as well. Silver is a 5s2, 4d9, that's considered unstable. Another one is chromium with 4s2, 3d4, that's also unstable. So all of these will promote one electron from the s orbital into the d orbital, and that gives it a stable configuration. Okay, so this is what actually occurs for copper. Silver will move one from the S into the D. Chromium will move one from the S into the D for that stable configuration. So this is how you fill out an Aufbau diagram, or sometimes you'll see it as an orbital diagram. On the test, or on the AP practice questions and on AP test, they end up with these. They make it linear for you, so just get used to seeing that, but it's still in order from low energy to high energy. One of the things they'll ask you to do is to designate unpaired electrons, and what they mean is any electron that's sitting in an orbital by itself. So there's your unpaired, those are unpaired, these are unpaired, these two. This is paired, okay? So just be able to pick out paired and unpaired electrons from there. The last thing that they will ask you about is ground state versus excited state. So I put the definitions of the two. So ground state configurations, it's lowest energy and most stable configuration. For most elements, you would get to ground state just by filling out a regular orbital diagram. So carbon has 6 electrons, so you can fill that out, and this would be considered lowest energy and most stable So this would be considered the ground state for carbon. And for pretty much any other element that you're going to be thrown with, that will be the ground state. There are three exceptions, and that's why I mentioned copper in the other one. These three will do something unique, right? I talked about how it's going to promote an s electron to the d orbital to make it stable. So this is not the ground state for copper because this configuration, a 4s2 3d9, is unstable. That does not fulfill that requirement. So this is the ground state for copper, ends in a 4s1 3d10. So these three elements will have a ground state that's going to be a little bit different from when you just fill in the orbital diagram straight. Okay, so those are the two cases for ground state. An excited state is when you get an electron that absorbs some energy and it jumps to a higher energy orbital. So here's an example of the 2s electron for carbon absorbing some energy and it jumps to a 2p orbital. That's higher energy. You can take a 2p electron and jump it to maybe a 3s orbital. That's a higher energy orbital. So as long as you've got an electron in the ground state jumping to a higher energy orbital, then that's considered an excited state. So here's excited state. Okay, so that's it for Aufbau diagrams, unpaired electrons, ground states, and excited states. And that, I promise, is the very last bit. If you guys have questions on any of those, you know you can always email me, catch me at a tutoring time, or ask for some one-on-one help. All right, thanks, bye-bye.